In this video, we're going to take a look at quartiles. And quartiles are another measure of position, measure of location. They're denoted Q1, Q2, and Q3. They're going to divide our data set up into quarters or into fourths. It divides it into four groups with about 25% of the data values in each group. Here, Q1, that is the 25th percentile. Q2 is the 50th percentile, and Q3 is the 75th percentile. So here, if we wanted to find our first quartile, we could take 25 over 100 times 20 to get a value of 4. Since that's a whole number, we are going to go 1, 2, 3, 4 data values, and halfway between the fourth and fifth data value, so halfway between 135 and 139, which is 137, that is going to be the data value that gives us the first quartile. For the second quartile, oh, I lied. This number is 5, and so we get 1, 2, 3, 4, 5. So halfway between the fifth value and sixth value. So we get 140. Gives us the first quartile. So 139 plus 141 divided by 2 gives us 140. For the second quartile, Q2, we take 50 over 100 times 20, which is 10. So we're going to go to the 10th data value. So this was the fifth value right here. 6th, 7th, 8th, 9th, 10th. So halfway between 152 and 153. So 152.5. Right there is where we found our second quartile. Right there is where our first quartile was. And then our third quartile, we take 75 over 100 times 20, because we have 20 data values, to get 15. So we want to go halfway between the 15th and 16th value. So this was our 10th value, 11, 12, 13, 14, 15. So halfway between 176 and 178, or 176 and 181, and that value there is 178.5. And so those are our quartiles, Q1, Q2, and Q3. The quartiles, those are part of a 5-number summary. 5-number summary, as you might imagine, consists of 5 numbers. The first number is the minimum value. Then we have each of the quartiles written in order, from smallest to largest. And then we have our maximum data value that shows up in this data set. So if we want to do a 5-number summary for the hot dog data set, 111 was the smallest number. We had 140 was Q1, 152.5 was Q2, and 178.5 was Q3. Our maximum value is 190, and those are the 5 numbers that summarize the data set. It tells us the smallest value is 111. From 111 to 140, there's about 25% of the data. From 140 to 152.5 is 25%. From 152.5 to 178.5 is another 25%, and from 178.5 to 190 is the remaining 25%. We can describe this visually with a box plot. So for a box plot, we find the 5-number summary. We construct a number line that contains both the minimum and maximum data values. We construct a box that extends from Q1 to Q3 with a vertical line in the box at Q2, and we draw lines out from the box to the min and the max. So here we have a number line. Let's just call this 110, 120, 130, 140, 150, 160, 170, 180, and 190. Our first step after we have our 5-number summary is to identify the minimum values and the maximum value. So our minimum value is right here. It's 111. And our maximum data value is right there, right at 190. We're going to construct a box that goes from Q1 to Q3. So Q1 is at 140. Q3 is at 178.5. So we're drawing a box that extends there. In that box, we're going to put a vertical line at Q2. So Q2 is 152.5. And then finally, we are going to draw lines that extend from the box to both the minimum and the maximum. And that is a box plot. Sometimes you'll see a box plot drawn vertically. With this box plot, this whisker, it's sometimes called a box and whisker plot, but this indicates that that first 25% of the data, this portion is the second 25% of the data, the third 25% of the data, and the last 25% of the data. I can look at this and see that there is quite a bit of a spread in the first 25% of the data. The second 25% of the data is clustered a little bit more closely. The last 25% of the data is clustered a little bit more closely. So those are things I can look at the picture and just see this is close, it's packed in together. This stretches out, so it's spread out a little bit more. We could also create a modified box plot. It extends out to the smallest and largest data values that are not outliers, and it puts an asterisk at each of the outliers. So you might say, well, how do I know what an outlier is? And I'm glad you asked, because that's what we'll look at in the next example. In the next video, we will see you there.